All right, so we were just talking about how we can pair up different sides in order to make a ratio in one of these right triangles. I can pair up opposite over adjacent, opposite over hypotenuse, something like that. Each one of those pairings, each one of those ratios is a trig ratio, and we're going to try to figure out what each one of them is supposed to be. So in order to do that, I'm going to do a little bit of measuring here. I'm going to measure each one of these sides, so I need to call up the geometry. I already have angle A measured, and let's see what that's measured in here. Okay, so notice that it measures that as, it's right here, it's this last one. It's beta, that's the Greek letter beta, is the angle between C, A, and B. Right now it's the 29.9 degrees. All right, so that part's measured. And then I need to measure the opposite side, the adjacent side, and the hypotenuse. I'm going to measure each one of those things. So to measure that, let's see, I have got, does it already measure it for me? No. All right, but it has the names of each one of these, hypotenuse, opposite. Where's my adjacent? Oh, it's way up there at the top, adjacent. Maybe it alphabetizes it. So what I'm going to do is I'll just try it in the calculator right here, down here at the input. And I'm going to divide those, divide the ratios that we mentioned. The first one that we mentioned was opposite divided by hypotenuse. And I should be able to just type in the names of those things that we called it. OPP for opposite and HYP for the hypotenuse. And on this keyboard here, I select the ABC. If you're using your laptop, of course, you just have your keyboard you can type in. So I am going to type in OPP for my opposite side, and then I'm going to divide it. So I need the 1, 2, 3 menu up here at the top. So I can hit division, go back to the ABC menu. Oh, dang it, that was not. That was plus. I don't want to add these things. Go back over here, I want division. There's the division. Okay, go back to the ABC menu and then HYP. And let's hit enter, and notice that it says 0.5. All right, let me collapse this and then just move this thing around. And notice that whenever I change the angle there, the opposite and the hypotenuse, opposite over hypotenuse, that ratio is correspondingly going to change. All right, let me put it someplace like this. And now let me move point A. Now look at it. The angle stays the same, and the ratio of opposite to hypotenuse also stays the same. Why is that happening? The reason why that's happening is whenever I'm doing this right now, angles staying the same, which means this is just dilating our shape, and our shape is staying similar. So the ratio of their sides should remain the same, be proportional. Okay, it's one of the kind of things that makes trigonometry so useful here. Let's do another one. Let's do the adjacent over hypotenuse. So I already have my keyboard called up, so ADJ for the adjacent side. Didn't spell that right, ADJ. Why is it saying 0.6? I don't even know. Divided by, I need the 1, 2, 3 menu, divided by the hypotenuse. Go back to the ABC menu, HYP, and hit enter on that one. This time I get a 0.6. And again, I can move stuff around and see that that changes as well. But notice that they're not the same number, right? Opposite over hypotenuse and adjacent over hypotenuse, not necessarily the same number. Could they be? Oh, yeah, right about there they were. Or at least rounding to. Now notice I only have 1 decimal place of accuracy. I can increase that if I change it in the settings, but for right now, for us discovering what each of these ratios are, just having 1 decimal is just fine. All right, I've got one more ratio to measure, and that is my opposite over adjacent. So OPP divided by ADJ. Enter. All right, and so now I have another ratio measured, and I can see that all of these things change. I got 3 different ratios. One of them is sine, and one of them is cosine, and one of them is tangent. We're going to figure out which one is which. Okay, and so in order to do that, anytime I do a sine or a cosine or a tangent, they're functions. And as functions, they need an input. So let me come back over here and write something down here. So let's say, for example, I wanted to find the sine of something. The sine has an input, and that input, this is like a function like f of x kind of function, and the input here is always an angle measurement. And that angle measurement can be in degrees, like we ordinarily use in geometry, or it could be in radians, and that's definitely what you'll use in pre-cal and calculus. So for us, it's the angle A here. In this particular example, it would be the 29.9 degrees. That would go inside there for x. Okay, so I'm come back over here to GeoGebra, and I'm going to input our angle measure. I'm not going to type the number. I want it to be dynamic. In other words, that it changes. It'll change depending on what that angle actually measures. So I'm going to use the variable that's right up there, which is the beta. So I'll go to the function menu this time, the f of x function menu, and you can see right across the top is sin. So I'm going to click sin, short for sine. And then inside there, it's got a little set of parentheses because it wants an input. It is a function and it requires an input. And our input is the angle measurement beta. And you can see across the top, you have 1, 2, 3, f of x for function, a, b, c for the alphabet, and then you have the Greek alphabet as the last one. So I'm going to select that one and choose beta, which is down here in the bottom, boop, boop, and then hit enter on it. Okay, so now what I've just done is I've measured the sine ratio of that angle. Currently it's 35.3 degrees, and it should match up with one of the ratios that are on the screen. So just look, I'm going to move this thing around. You move it on yours as well, and what changes? Which one does it stay the same as? Is it opposite over hypotenuse? Is it the adjacent over the hypotenuse? Or is it the opposite over the adjacent? Let's see. All right, so there were some times where the opposite and the adjacent were the same thing as the sine, but that's not it. Right now, you can see that very plainly it's the opposite over the hypotenuse. Sine is that ratio. The sine of your angle is the ratio of the opposite over the hypotenuse. All right, let's try the next one. Let's try cosine. Go back over here to functions, cosine, put our angle measurement of beta in there, so I'll have to get the Greek alphabet and type in beta. And now this time I get 0.8. And you can see that 0.8 is also one that's on here. Which one is the 0.8? Well, now it's 0.9. It's the adjacent over the hypotenuse. That's the one that it matches up with. Right? And then we have one more to try, which is the tangent. I wonder what it's going to be. So I'll select the function, the tangent, put in my angle measurement one more time. Angle beta, hit return. And I can see that the tangent, which now is 0.4, it's matching up with a sine. It's matching up with a sine, but it's also matching up with the opposite over adjacent. I need to change it to something else. Now 0.7 for the opposite over the adjacent, and that's different from the sine, which is the opposite over the hypotenuse. Right, so it is possible that some of the sine and cosine and tangent ratios are the same. It depends on how they are arranged on that particular right triangle. So we're going to recap this in the next video where we'll formally define what the sine, the cosine, tangent ratios are. And as we can see from this investigation, it seems like the sine of our angle is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And lastly, the tangent is the opposite over the adjacent.